Episode 16. The title of the radio enabled learning course is Energy Physics, Unit 4, Energy from Biomass. In this episode, now we will see about classification of biogas plants. Biogas plants are mainly classified as continuous and batch type as per the process. Second one is the dome and the drum type. The third one is different variation in the drum type. The main features of continuous plant are that it will produce gas continuously, it requires small digestion chamber, it needs lesser period of digestions, it has less problem compared to batch type, and it is easier in operation. The main features of batch plants are the gas production in intermediate depending upon the clearing of the digester. It needs several digesters or chambers for continuous gas production. These are fed alternately. Batch plants are good for long fibrous material. This plant needs addition of fermented slurry to start the digestion process. There may be a direct change to the acid phase in the absence of fermented slurry, which affected formation of methane. This plant is expansive and has problems comparatively. The continuous plant will have less problem and will be easy for operation. Then we will see about advantages and disadvantages of floating drum plant. First advantage, it has less scum troubles because solids are constantly submerged. No separate pressure equalizing device needed when fresh waste is added to the tank or digested slurry is withdrawn. In it, the danger of mixing oxygen with the gas to form an explosive mixture is minimized. Higher gas production per of the digester volume is achieved. Floating drum has welded brasses which help in breaking the scum floating matter by rotation. No problem of gas leakage. Constant gas pressure. These are the important advantages. Next we will discuss about disadvantages. It has higher cost as cost is dependent on steel and cement. Heat is lost through the metal gas holder, hence it troubles in colder region and periods. Gas holder requires painting once or twice a year depending on the humidity of the location. Flexible pipes joining gas holders to the main gas pipe requires maintenance as it is damaged by ultraviolet ray in the sun. It may be twisted also with the rotation of the drum from mixing or scum removal. Advantages and disadvantages of fixed dome type plant. Advantages: it has low cost compared to floating drum as it uses only cement and no steel. It has no corrosion trouble. In this type of heat, insulation is better as construction is beneath the ground. Temperature will be constant. Cattle and human extra and long fibrous style can be fed. No maintenance. The disadvantages are this type plant need the service of skilled mason who are rather scarce in rural area. Gas production per cum of the digester volume is also less. Scum fermentation is also problem as no stirring arrangement. It is variable gas pressure. Next we will discuss about biogas from plants waste. The subject of biogas production from fresh plant waste is not at all new. Biogas production was a common feature even 40 years ago on many European farms. The biogas was used in kitchen oven, chicken hatching, washing machine, automobiles and other IC engines, room heating device, refrigerators, etc. These plants were essentially batch fermentation plants which had heating system. The process of biodigestion, as already described, is carried out generally in the following two recognized systems: batch fermentation and continuous fermentation. In batch fermentation, the feeding is in between interval. The plant is emptied once the process of digestion is complete. In continuous fermentation, the feeding is done every day and digest slurry equivalent to the amount of feed overflow from the plant. The continuous process may be completed in a single stage or separated into two stages. First, we will discuss about single stage process. The entire process of conversion of complex organic compounds into biogas is completed in a single chamber. This chamber is regularly fed with the raw material while the spent residue keeps moving out. Serious problems are encountered in a single stage continuous process. This subject is discussed separately. Next, double stage process. Acidogenetic stage and methanogenetic stage are physically separated into two chambers. This is the first stage of acid production is carried out in a separate chamber and only diluted acids are fed into the second chamber where biomethane take place and biogas can be collected from the second chamber. Considering the problems encountered in fermenting fibers, plant waste material, the two-stage process may offer high potential of success. However, appropriate technology suiting the rural India is needed to develop based on the double stage process. Wet and dry fermentation. Wet fermentation. In this case, the digester is largely filled with water so that the dry matter generally remains less than 10%. The material similar to cow dung ferment very well in this process. However, fresh plant material being light float on the water forming a scum. This scum must be broken and the material are submerged every few hours to maintain continuity of the process. This is the major problem encountered while fermentation agriculture waste by this process. Dry fermentation. In order to prevent floating of the plant material on water, the amount of water in the digester is kept to its minimum, which is just sufficient to keep the raw material wet for its active fermentation. The total solid may be 25 to 30% with no free water. This process is called dry fermentation. The problem of floatage and scum formation may or not arise, but the accumulation of acid and entrapment of the gas is plant material is likely to occur. The plug flow or movement of the plant material in the digester may also not take place. Thus, the problem of pH regulation, proper uniform culture development and movement of the material pose serious problem in this process. Some of these problems may less serve when dry fermentation is carried out in the batch fermentation process. Next, we move on to pilot plants using plant waste. There are many wastes such as paddy straw and wheat straw, water, etc., which can be utilized to generate biogas. A domestic biogas plant of 0.4 meter cube capacity was developed and fabricated at Jyoti Solar Energy Institution, Vallabh Vidyanagar, Gujarat, which could be placed inside the kitchen and save 50% LPG requirements of the family. This plant uses water, a water wheat available in many parts of India. It is very fast growing aquatic wheat. Its annual productivity is about 1050 tons per hectare of water surface. This waste can be fed into biogas generator to generate biogas. Physicochemical characteristics of water hyacinth. Physical characteristics: moisture is about 92.87%. Total solids is 7.13. Residue is 1.31. Chemical characteristics: carbon is 32.51%, hydrogen is about 4.22%, nitrogen is about 1.78%, cellulose is 25%, lignin is 10.99%, carbon to nitrogen ratio is 18.26%, specific gravity is 0.25%. Moisture and total solids are on wet weight basis, and all the other analyses are on dry weight basis. From the above, we see that water has a very high content of moisture, and 83% of its total solid are. Its carbon to nitrogen ratio is 18.26 and cellulose content is 25%, which shows that it has good potentiality for biogas production. The results of experiments on water hyacinth for biogas production. Biogas production per kilogram of wet water hyacinth 53.50 liters. Biogas production per kilogram of dried water hyacinth 750.61 liters. Next, we will discuss about community biogas plant. Besides the individual family size biogas plants, promotion of community and institutional biogas plants might also help in solving energy problems. The investment which is required for individual biogas plant is beyond the reach of very large section of farmers in poor countries. Through a capital cost up to 75% is provided by Department of Non-Conventional Energy Sources DNES in India. Still, the larger number of poor farmers are not in position to have individual biogas unit. Moreover, this technology, especially in India, can be benefit only those farmers who have more than 3 to 4 heads of cattle. Such farmers form only a small percentage in most of the developing countries. Another point in favor of community plants is that the small individual plants cannot be met the given cost of maintenance staff, without which the success of program cannot be achieved. The installation of bigger size plant for a group of families or a community is recommended to avoid all the difficulties mentioned above. These plants are more economical than individual plants. A community plant system will nearly always have more gas than required for domestic use. The extra gas can be used to generate electricity, which can be used to light the village, homes, streets in the first place, and for pumping water, running chaff cutter, flour mill, and other industries. This will reduce the fossil fuel requirement. it has been demonstrated that 5 lamps can be lighted with electricity generated from gas used by one gas lamp. Anaerobic digester maintained at 35 degrees Celsius generate 33.3% more gas in one-third of digestion period. Compared to those operated at ambient temperature, engines are being run on biogas to generate power and also to heat digester. A total energy molecule consumes 10 cum biogas, that means 50,000 kilocalories, delivers 15 kilowatt power, 30,000 kilocalories, and hot water at 60 degrees Celsius to 80 degrees Celsius. That means 33,000 kilocalories. The total efficiency is 92%. These units have been made possible to operate biogas plant in cold countries successfully, where it was economic to use them so far. Several problems will have to be solved before the community plant can successfully operate. Quick method to detect quantity of earth mixed with cattle dung as well as total solid has to be worked out. Collection and transport of all waste including cattle dung has to be managed. Pre-processing of agriculture waste and cattle dung to remove earth, sludge, gravel, etc. has to be worked out. Cheap heating of the digester with solar heater and waste engine heat have to be standardized. Waste wood is available in all villages. Its gasification will have to be done so that a common mode of using all energy source is established. Gas piping is costly or not easy to maintain. Correct gas pressure during cooking hours mean that gas pipes will have to be big enough to maintain peak cover. Flow without pressure drop. The measurement of gas is essential and gas meters are costly investment of gas pipes, and meter may be offset the economic advantage of bigger community plant. Cost of materials, construction and of the land is reduced inversely by square of the capacity of the plant. Bigger size plants are cheaper. These plants can be developed and can be made much more efficient and managed professionally. Organic waste like agriculture, byproducts, sweeping, waste paper, leaves and night soil from community attached to the community plant can also digested to obtain much more fuel gas and organic fertilizer. A system of community plant in village can make the village absolutely clean, get rid from smoke, flies and parasitic foams. The families will not much more collect fuel, refuse, waste wood, etc. for use. Domestic fuel can sell it to the community plant or exchange it for gas. The community biogas plant requires through the planning and perfect management, since the failures, if any, will ultimately cause a setback to implementation of the entire program. It would be advisable to have at least 2 small size plants in place of one big size plant. Similarly, the plant using human may be separate to enable the use of the gas for lighting rather cooking. This will make for easier acceptance of the community plan by the beneficiary. Similarly, for the organizational efficiency, it would be better to limit community plant to some 50 to 60 households rather than an entire village community. This, of course, will not apply in case of big institutional plan meant for establishments like hostels, educational institutes, hospitals, big dairies, stables, etc. Digester design considerations. Digestion tanks may be of any convenient shape and provided with a cover to retain the gas. The cover may be fixed, on or floating. A number of factors are to be taken into account to arrive an optimum size of biogas plant. The volume of waste to be digested daily. The type of amount of waste available for digestion consistently. Period of digestion. Methods of stirring and contents if any. Methods of adding the raw wastage and removing digested slurry. Efficiency of the collection of the raw waste. The climate condition of the region. The available of the other cellulosic fermentable waste in the area. Information about subsoil condition and water table. Type of the cover. These are the important things to be considered to design the digester. Economics of energy obtained through plantation will essentially depend upon cost of the fuel mass produced in the comparison to conventional fuel. Cost of processing required, if any. Cost of the fuel will depend on cost of land used. That means in turn the yield of the fuel per unit area per year. Cost of the plantation per unit area per year. These are the important things. Some important applications of gasifiers. The gasification technology has tremendous potential in terms of its application, as the process output can be converted into a electrical, mechanical or heat energy. The potential application of the gasifier can be analyzed based on the total energy requirements in particular application. Small size gasifier, medium size gasifier. The small size gasifier produce up to 10 kilowatt. Medium size gasifier is produced up to 10 kilowatt to 50 kilowatt. Next, direct thermal application. The applications are cement manufacturing, glass making, brick making, ceramic and pottery, rubber manufacture, food processing, brewing, crop drying, fertilizer production and chemicals. Dear student, now we are in the end of the unit 4. Now we will discuss about some important questions in unit 4. Biomass. How biomass conversion take place? What is the difference between biomass and biogas? Explain the process photosynthesis. What are the conditions which are necessary for it? What is meant by anaerobic digestion? What are the factors which affect biodigestion? Explain briefly. How are biogas plants classified? Explain them briefly. What are the advantages and disadvantages of floating drum plant? Name the various model of biogas plant. Explain the constructional detail and working of KVIC digester. What is meant by wet fermentation and dry fermentation? What is community biogas plant? What are the main problems encountered in its operation? Write the main applications of biogas. What is meant by energy plantation? What are its advantages and disadvantages? What are the main plans proposed for all energy plantation, especially in India? How are gasifiers classified? What is pyrolysis? Thank you.